Welcome to the curriculum hotspot for LS16. This is part of the Molecules to Organisms, Structures and Processes. For this lesson, we'll be using the Science and Engineering Practice 6, which is to construct and revise explanations. This is our Cho-Cho-Chan's Chomp, which many of us remember as our carbohydrates, lipids, proteins, and nucleic acids. The main point of this lesson is to get across how we can take the same molecules, carbon, hydrogen, and oxygen, and transform them into some of the other elements necessary for life. Keep in mind, we do not include those chemical reactions. All right, so standard 1.6, Life Science 1.6, will be woven throughout several lessons. The first is in lesson 1.5, where we talk about organic molecules, and they examine those macromolecules. They learn about the atom. We're going to focus on the carbon atom and its bonding. And then this actually leads us into the project for quarter one. So we want to make sure we really focus and give them a good foundation here. And then the Science Expo. So that's really important for their foundation in Science Expo. Part of understanding the organic molecules is knowing the structure of carbon specifically, making sure that students can draw this, create a model of it, and see that the first 2 electrons fill that first shell, and then the next 4 electrons go into the outer shell, leaving 4 bonding sites. Using the periodic table can be very helpful because you can revisit some of the skills that students may know about the periodic table. For instance, anything over with hydrogen is going to have 1 electron in its outer shell and is going to want to use that electron to perhaps share with another atom that would need an electron, like carbon. So you could, after drawing the carbon, show how hydrogen would bond and fill at least 1. So if we did 4 carbons, we'd have methane, and we could have a stable atom. Now, you could also add oxygen in, and the students would be able to now see that that has 6 electrons if they're using the periodic table in its outer shell, and then they'd be able to think and talk about, well, what could bond there? Maybe we could get an OH, maybe we could get a double bond to carbon. And even though this stuff is not necessarily assessed, it helps students get the deep understanding for how these bonds are forming, so that when they see them later on, it'll make a lot more sense. So even though we're going to be teaching these structures, students do not need to memorize the reactions that are involved here, and they do not need to memorize the structure of carbohydrates, lipids, proteins, and nucleic acids. So you are going to be showing them those amino acids, those lipids, those sugar molecules, but you're looking at them and trying to deduce patterns, and that's where that foundation you laid with your carbon molecule is going to help play into this, because they should be able to see those carbon, hydrogen, and oxygen bonding going on in there, and see how there's a relationship between amino acids, lipids, and of course that glucose molecule that we made. There is a really good Discovery Ed video, and they can do the arts integration. I see, I think, I wonder. Working with models really helps students gain a deeper understanding of what they're doing. There are the ball and stick models, but I like these ones here that I've linked called Cell Zone. When you open that up, you'll see that there's little plastic molecules that you can put together. And on the molecules, you'll see carbon, hydrogen, oxygen, and that really does help reinforce this. Keep in mind that we're not teaching the reaction. So these kits do allow you to see hydrolysis, dehydration, synthesis. They have water molecules with them, but you do not need to teach that. A good DI is this eMine simulation. There is a process guide that students can use as they work through the eMine simulation. If you're unable to secure any models, or you find that it might be easier for students to understand, the PhET simulation Build a Molecule is available, and the online textbook has a sort of hands-on modeling activity that you can use as well. Remember that textbook is online for students to access. All right, now we've pretty much wrap things up. We're ready to do our SEP 6, where we're constructing and revising explanations. The link to the formative assessment is in the curriculum. And when you look at it, the third bullet is something that's a little bit challenging for students. It talks about energy released and absorbed during breaking and forming of bonds. And I know we all say energy is released in the breakdown of glucose. It's actually not completely true if we say it that way. Breaking bonds requires energy input, and forming bonds releases energy. Now, how do we get the energy that we're talking about when we break down sugar? We actually get it when new molecules are formed, when that large complex glucose molecule is broken down or that lipid molecule is broken down. The energy that's released is actually in the formation of things like water. So that is a challenge for students, and it is a big misconception. I know our AP chemistry and AP biology teachers would be very thankful if we could help clear up that misconception. So building a good foundation is always important for us to continue to build upon as we move forward. When we get to photosynthesis, we're going to be revisiting this idea of this bond formation, the breaking of bonds, how glucose is formed, and what glucose can be used for. So please make sure that students have a really good foundation here. And it's also good because it's going to lead into our project.